Good day. My name is C-Jhay and the subject is Compre 2. The topic is footings and slab USD. So problem number 1. A one-way slab has to carry a service live load of 4,000 Pascal. It has a length of 4 meter with both ends continuous. Assume 4C prime is equals to 21 megapascal and Fy is 415 megapascal for main bars, and Fy is equals to 276 megapascal for temperature bars. The steel cover is 20 millimeters. The unit weight of concrete is 23.5 kilonewton per cubic meter. So, determine the required spacing of temperature bars. So, meron na tayo dito, yung given natin na live load. Lahat, nandiyan na. Sinulat ko na lang. So, first, solve natin yung total cross section area of the temperature bars. So, solution P is equals to 0.002 base times height. So, 0.002 is yung base natin na 1,000 times 150. So, makukuha natin dyan is 300 millimeter squared. So, solve naman nga natin yung spacing na. So, which is yun yung hinahanap. So, S spacing is equals to total cross section area of steel over cross section area of steel. So pi times yung 10 mm squared natin raised to 2 all over 4 all over 300 mm squared jam times natin sa 1,000. So, makukuha natin yung spacing natin, which is 261.799 mm. So, nakuha natin sa spacing is 261.799 mm or 260 mm. So, checking for spacing tayo. So, okay, is maximum spacing is equals to 5H equals to 5, yung H natin na 150 is equals to 750 millimeters. At sabi naman, yung maximum spacing natin is 450. So, since yung nakuha natin dito is greater than sa nakuha nating spacing, so, ang gagamitin ngayon natin is yung na-compute natin na spacing. So, ito yung pinaka-sagot natin. So, the second problem is katulad lang nung kanina. One-way slab has to carry a service live load of 4,000 Pascal. It has a length of 4 meter with both ends continuous. Assume 4C prime is equals to 21 megapascal and Fy is 415 megapascal for main bars, and Fy is 276 megapascal for temperature bars. The steel cover is 20 millimeters and the unit weight of concrete is 23.5 kilonewton per cubic meter. So, determine required spacing of main bars. So, ang pinagkaiba lang dito, ang hinahanap naman ngayon dito, kung kanina ang hinahanap is yung temperature bars, yung spacing ng temperature bars. So, ang hinahanap naman dito, yung spacing ng main bars. So, first, i-consider natin na yung meron tayong 1 meter strip. So, which is B 1,000 millimeters. So, compute natin yung uniform live load. So, which is ang formula natin is W live load is equals to 4 kilopascal kilopascal siya, so is equal siya sa kilonewton meter squared times natin sa 1 meter para maging 4 kilonewton meter na lang siya. So calculate ngayon natin yung minimum slab thickness. So H minimum is equals to L over 28. Yung L natin is 4,000 given yan. So divide natin siya sa 28 and makukuha natin sagot is 142,857 millimeter, or gawin natin 150 millimeter. So compute naman ngayon natin yung compute naman natin ngayon yung weight of the slab or yung dead load natin. So sulat natin dito unit weight ng concrete times yung length or yung base times height or yung depth. So 23.5 unit weight ng concrete times 1 times 0.15 na depth. So makukuha natin is 3.525 kilo pascal. Then compute naman ngayon natin yung factor dead load and live load, which is yung WU. So formula natin dito is 1.2 times yung dead load na nakuha natin. Ano yung dead load na nakuha natin? 3.525. So ito yan. Then yung live load na nakuha natin kanina, plus natin sa 1.6 times yung live load na nakuha natin kanina, which is yung 4. So makukuha natin dyan is 10.63 kilo pascal. So meron na tayong dead load, live load, kaya nakuha natin yung factor na dead load and live load. Then effective depth, kunin natin D is equals to 150. Nakuha natin dito sa minimum height, minus natin yung 20 millimeters minus 1/2 times natin sa 12 millimeters. So ang makukuha natin dyan is 124 millimeter para sa effective depth natin. So calculate naman ngayon natin yung midspan natin sa ultimate moment. So mu is equals to formula natin dyan W ln squared all over 16. So W natin is, yung nakuha natin kanina is 10.63 times 4 squared all over 16. So makukuha natin ngayon dyan is 10.63 kilo pascal. So para naman makompute yung concrete design ratio, design ratio, gamitin natin yung formula na mu Rn BD squared. So mu natin na nakuha is 10.63 equals to 0.80 times yung Rn na hinahanap natin, concrete design ratio, times yung 1,000 na length natin and yung depth natin na 124 squared. So makuha natin sa concrete design ratio is 0.768152 megapascal. Dadisog lang natin. So susunod natin, computerin ngayon natin yung reinforcement ratio. So computerin ngayon natin, which is 0.85 FC prime over Fy times 1 minus square root of 1 minus 2 Rn over 0.85 FC prime. So substitute lang natin 0.85 times yung FC prime natin na 21 all over for 15 na Fy natin times 1 minus square root of 1 minus 2 yung Rn na nakuha natin 0.768152 over 0.85 times yung FC prime natin na 21. Makukuha natin dun is 0.0189261. So ngayon yan yung reinforcement ratio natin. So check ngayon natin yung minimum reinforcement ratio natin. So dapat hindi mag-exceed yung na-compute natin na to sa minimum reinforcement ratio natin. So compute natin minimum 1.4 over Fy equals to 0.4 0.0037349. So ito yung minimum reinforcement ratio natin. So since mas mataas yung nakuha natin sa minimum reinforcement ratio natin, ito na ngayon yung gagamitin natin. So compute na ngayon natin yung total cross section sectional area. Still AS equals to base tsaka height times sa nakuha natin na reinforcement ratio. So AS is equals to yung nakuha natin 0.0033734 times natin sa 1,000 yung length natin times sa depth na 124. Ang kuha natin is 418 millimeters squared. So susunod ngayon natin yung pag-compute ngayon natin sa spacing natin sa main bar. So katulad kanina, spacing is equals to ASP over AS. S natin, substitute lang natin. Ang formula nitong AS natin is pi times 12 squared over 4 times natin sa all over 418 times natin sa 1,000. Kukuha natin dyan is 270.568 millimeters or 270 millimeters. So checking tayo, checking for spacing. A yung max na spacing natin is equals to 3H. So 3 times yung depth natin na 150. Nakuha natin is 450. And yung B natin is 450. So since yung maximum spacing natin is mas mataas sa nakuha nating spacing dito, so ang gagamitin ngayon natin itong 270. So ito yung ay nahanap na spacing of main bars. Ito na yung magiging sagot natin.